Let's try that again. Let's see if my mic is working now. Are we good? I'm checking out my mic. I'm checking to see. Okay, cool. Let me try that one more time with sound this time. Again, hello and welcome everyone once again to the Zapple Tech Text Automation Meetup, where we get together about once a month and have wonderful guests that come in and talk a lot about what they are doing in their career. If this is your first time here, welcome to here. This is I'm Paul Grossman, the Dark Arts Wizard, and over there on my other side there is Lou Robinson, who is our first guest speaker out here. Lou is working out of he's in Westmore's, England, in the United Kingdom, and he is working for a company out there which is Silvera, which is a very interesting place. And I'm really excited to have him on board. We will have another speaker in the second hour, but it's a surprise. We actually had one speaker kind of drop out, so we're going to do something kind of fun with a game of Stump the Automation Engineer with some codeless test automation, but that's for the next hour. And Lou, let me check your mic. Can you hear me okay?
Yeah, I can hear you. Can you hear
And
me?
I can hear you too. Cool. You didn't make the same mistake I did. As I just a quick one other thing is that I'm Paul Grossman, the Dark Arts Wizard. That's why I've got the funny hat on, just hiding the receding gray hairline over there. You can catch me on Twitter, talking all sorts of other stuff about automation, and that's all I really do. And I'm going to say, basically, let's see, Lou, you've got a presentation over here. I think you said what is the name of the presentation? It's something like
Delusions of automated testing.
That's what I was thinking. Delusions of automated. I suspect somebody at some point you're going to say, "Hey, let's automate everything. Get 110% automation done." So I'm looking forward to this. I hope everybody is excited. I'm really looking forward to this. Lou, I'm going to pass over to you and take it away, my friend.
All right, let's see if the screen sharing goes as well as everything else. I think it's going to be okay. Ta-da! Can you just see the slides?
I can see the slides on my side.
Yes, I was so convinced that was going to go wrong. Okay, hey, I'm Lou Robinson. Without further ado, I guess I'll just crack on. Delusions of automated testing. So, no, that's not what I wanted to do. What is a delusion? So, delusion is an idiosyncratic belief or impression maintained despite being contradicted by reality or rational argument. This is the worst definition I've got because it had idiosyncratic in it, and I thought that's a terrible word to put in a description. So, what is idiosyncrasy? A strange or unusual habit, way of behaving, or feature that someone or something has. So, pairing those two things together, a delusion is ultimately someone having a strange or unusual belief that they maintain despite being presented with evidence. So then what is testing? I've stolen this from James Back, like no shame there. James Back, for those of you that don't know, I mean, it's hard to not know who James Back is in the testing field generally, but James Back is one of the pioneers of software testing. Wrote a book years ago called Lessons Learned in Software Testing, which to this day is still an amazing read. But anyway, testing is the process of evaluating a product by learning about it through experiencing, exploring, and experimenting, which includes to some degree questioning, study, modeling, observation, inference, etc. Which I think is a pretty good definition because it kind of encapsulates all of the things that we do as testers, which in my next point is going to become super apparent like why I've made this point. I'm sorry in advance for anyone who I trigger by any of my like controversial opinions about automated testing. I don't think it's a bad thing. Well, we'll get to that. So, moving on. I've highlighted 4 of these words specifically, just because I wanted to kind of draw something out. And they're those of you that are in the testing community and have been for some time and kind of like listen to what's going on, will be aware of these sort of like issues we have around automated testing, whether testing can truly be automated and so on and so forth. So, with that definition, well, you can see here, like, can code experience? No, code cannot experience. Code cannot explore. Code cannot experiment. Code cannot question things. I mean, there are, at a stretch, you could argue that there are some artificial intelligence platforms that maybe can kind of like imitate some of these things, but ultimately it's still a human behind those things. A computer will only ever do what we have told it to do. So if we've thought about scenarios and so on and so forth, and we've programmed them in, a computer can kind of mimic what we do as testers. But trying to get to that point where an automated test can do exactly what a human being would do when they're testing is, based on this description, I think is unattainable at this stage anyway. So what does automated testing really mean? And this is obviously just my experience and observations throughout my career, but we validate functions. Like, there is plenty of cases where you can see that we validate a function does exactly what it's supposed to do at the unit test level, integration test level, end-to-end test. You're just validating functions based on the inputs and outputs. So you put something in, you create a system state, and you check that it behaves in a certain way. And you can make them somewhat more complicated to make them more like a scenario, but ultimately you're still just adding more inputs and outputs and checking that those things are what you expect. Oh, I keep pressing this thing and it keeps taking me off to my dictionary, which is really annoying me. So why is that good? I mean, so there are obviously positives with that. If we can automate those things, that reduces the strain on testers. We can run tests a lot faster if a computer is running through them and validating all these things. If you have a human being do that, something that might take a computer 30 seconds is going to take a human being a couple of hours potentially. It provides fast feedback. Again, the same sort of line of what I was saying. If a computer can do something that fast, you can get that feedback much quicker, and you can see where the problems lie without having to infer them and explore yourself manually, as it were. It speeds up delivery cycles. Again, all of this stuff is basically reliant on the tests being faster when they're run by a machine. And the last one is like super important. I think this is one of the biggest things one of the biggest gains we get out of automated tests is they're easily repeatable. Human beings have it's kind of a boon and a bane because we are really bad at doing the same thing again and again and again, exactly the same way. And that makes it really hard to reproduce errors sometimes. So sometimes you might see something, and like you get this with a lot of junior people in the testing and QA profession, right? Like where they'll be like, oh, I'm really good at breaking stuff. And half the time it's just because they're really good at doing things in an obscure way or an unexpected way that breaks things. But like trying to get them to reproduce those things is not something that they find as easy. The benefit of having a test do exactly the same thing every single time because a machine is doing it is that when it breaks, you know why it broke, and it's much easier to find that. There's obviously caveats to that. Sometimes you still find issues where like the system state, depending on how complicated your system is, has got into a particular place and something breaks and then you rerun it. I mean, flaky lesson, I'll get onto that later. But for the most part, easily repeatable means you can rerun it and you can see the same inputs and outputs being validated in the same way. So if something breaks, you can generally easily repeat it in order to debug. Is it all good though? So, and these are some pretty sweeping statements, which I will quantify later on, but it undermines the craft of testing. So there is as I alluded to earlier, there's a lot of debate in the testing community about whether you can actually automate testing because of the kind of 4 points I made earlier about whether code can actually do the things that we do as testers. There's a really good white paper actually by James Back on this, and it was about how compilers used to be called auto programmers, and they changed the name because it basically upset the development community so much. I actually think we're in a place in the testing community where the term automated testing has been used so much that there's no way we're ever going to get rid of it, and we kind of have to educate better rather than try and take it back or change it. It's just too much usage of the term, but it undermines the craft of testing by kind of delivering this belief to people that are not aware of how it works that you can automate that job entirely, which most of us will be aware that you can't do. It does not verify. You cannot ascertain based on the validation of inputs and outputs that a product that you're building is fit for purpose. Does it actually meet the expectations that we set at the beginning? A computer doesn't know. You've told it, like, does it do these things? Yes. Okay. Does that meet the goal that we set out to achieve? Don't know. Like it's too much like an inference about the behavior of the product required in order to actually answer those questions. So the verification element is still something that we very much have to do as human beings. Treat it as a silver bullet. Like a lot of people, I've worked at places like this where they're absolutely convinced that once they introduce automated testing and cover everything, they'll never see any bugs again. kind of what Paul was alluding to earlier when he said about 110% testing covered everything. It's never going to happen, and there's a lot of people that are under this false belief that's the thing. Automation testing is the next big step, and we're going to solve everything with this one thing, and requires maintenance. I cannot state enough how much work it is to maintain a big suite of automated tests, and it's only getting more complicated. There was a time when I first started doing automated testing where you didn't test the API. People weren't testing APIs. People were testing the front end of things, and that was it. That was the extent of automated testing. And now you have so many different frameworks, there's so many different ways to do it, and people have different ideas about the right way to do it, how to set up tests, how to tear them down, so on and so forth. And it's got very complicated. It's another set of development in its own right, and that people don't consider when they go, oh, well, let's just automate all these tests. So how it begins, I don't actually know. I was thinking about this when I was writing this, and I have no idea where the first automated test came from, or where it came from generally, the idea that testers own all of the automated tests, because as we all know, developers write all their own unit tests for the most part. So I don't know where this idea that testers own all of the automated testing from a more behavioral driven level came from. But anyway, I like to think it went something like this. So repeatable mundane test exists. Tester, I am sick of doing this test. Also tester, automates test. I mean, granted, you would have to have some degree of savvy about development practices and stuff in order to code a test in the first place. But, I can see a scenario where that happens. It probably happens all over the place all the time, because people get frustrated with the fact they're doing things over and over again, and they think, well, I'm gonna automate this, which is totally valid. That's a very good way. There's a very good reason to do something, right? And that's good, right? That sounds like it's a good thing. So I'm going to go through a number of slides now about how this spirals out of control and becomes a problem. This is where the kind of delusions element comes from. So automated tests becomes automated tests. Automated tests break whenever there is a change, which is fine. You expect tests to do that. You've introduced a change. You built it to a test to spit out an error one way or another, depending on what the output is based on the input you've taken. So if you change the behavior of the application, there's a high chance your test is going to break, which is acceptable. If it didn't, that would be worse. So tester then becomes automation tester, because what happens in that case is that they're constantly having to maintain those tests, which means they're spending less time verifying changes, because now their whole purpose has become maintaining these input and output checks, because every time a developer makes a change, they have to then fix that thing. One of the other reasons that this is a problem is that the scale is never set up correctly for testers to own automated tests. If you've got a lot of money and you're a huge company, you can invest in a whole team of automated testers, fine. For a lot of companies I've worked for, generally the ratio is several engineers, say 5 and 8 engineers to one tester or QA engineer, or whatever they're called in your company. But that doesn't scale. You can't have 8 people developing changes and another person responsible for verifying those changes and maintaining all of these tests. So, understanding your mitigation, automated tests do not replace the tests. And understanding that automated tests at a cost allow for more thorough testing elsewhere. That's the ultimate goal of automating anything. And there's also this kind of common misconception that automation in the tech space often refers to automated testing, and it doesn't, right? We have whole roles devoted to automating mundane tasks that people do, because that's the way forward. If you can do that and it's easily repeatable, then we should automate that. That makes everyone's life easier, and that means they can spend more time doing the stuff that's difficult. And for some reason, that is not a shared consensus across automated testing, because they don't go, well, we'll automate these tests so that they can spend more time testing other things. They go, we'll automate these tests so we don't need to hire so many testers, which means that you're just losing sight of why you were doing it in the first place, in my opinion. So where I've put at a cost here is because you're ultimately accepting there's a risk associated with this, because if you have a human being regression testing something, they've got that element of experience and understanding. As an example, if you have an API test that hits an endpoint and it's expecting a 200 response, for example, a human being, in fact, I'll go the other way around. So an automated test, regardless of how long say it takes 25 seconds to come back with a response. The test is going to go, well, that's still a 200, that's fine. and move on with its life. Whereas a human being will go, that's a really long time for that to come back. And that's going to be indicative like there's a memory leak or something, or you're not load balancing requests properly or something. But a human being can infer those sorts of things based on what they know already. An automated test is only going to do or check for exactly what you've told it to do. So you could totally add tests for that. You can add performance tests and something, but that's a whole other test suite that you've then got dedicated to something completely different. So that's more complicated tests you're having to add just to try and mimic some of what a human being can infer naturally, because we're inquisitive or curious or whatever. So I've now added this section. This seems a little bit self-indulgent, so I apologize for that. I just like coming up with stupid names for things. But the Lost Expedition of Blue Robinson, this is basically a way of me going through kind of relevant experiences I've had in companies. I've taken all the names of the companies out, and if you really wanted to, you could probably go on my LinkedIn and work out who they were. But the idea being that I've seen a lot of sort of these talks before where people don't really draw on their actual experience and give you like, these are the problems I faced, and here's how I went about solving them, or the lessons I learned, which I've always found kind of frustrating. So I thought, well, I'll try and do that for the benefit of everyone here. So there's an employee wellbeing startup I worked at, not for very long. They had a general sort of like lack of understanding about testing quality. This the CTO, who I butted heads with a lot, had this. He was absolutely convinced you could completely automate testing, and I had to keep arguing with him about that. Again, that's not really how it works. And they had a big drive for automated testing. That's what they wanted. They wanted automated tests. They didn't care. Like, so I was sort of saying, well, there's loads of testing that needs doing before we can automate this stuff. And the opinion was more like more automated testing is going to fix that problem. Fine. I mean, it's not my opinion, and they're in charge, so it's difficult to win that fight sometimes. And the larger quality problems, therefore, were being kind of ignored. So my takeaways on automated testing from that particular company is the drive for automated testing should be coming from the right people, basically. People tasked with the actual testing that understand why we're testing, what we should be testing, where the risks are. They're the people that should be saying, we should automate these tests, or this is a high-risk area that we have to keep testing, or this test is really complicated and it's easy to like get wrong. Let's automate those tests. Because if it's coming from upper management, they have a detached perspective on why we're automating those things. They go a lot of the time like, oh, I want to see coverage over everything, because then we no bugs are going to get through. And you go, well, one of the first things you learn in the principles of software testing, right, is that exhaustive testing is impossible. So you still have to be careful about the sort of things you're automating. And the other side of that is automated testing will never replace testing. I've kind of alluded to that before, but like it just reinforced my opinion on that. Like I've seen what they were doing, and like for example, this particular company had a client that sort of 140,000 users strong, and we had two testers, me and another person, and we weren't even working on the same product. So that's ultimately one tester pitted against 140,000 users. And I was going, there's no way we're ever going to find stuff as fast as them. The bigger, the more value add thing we can do in this sort of instance is try and prevent them happening in the first place, rather than trying to catch everything that's going to go wrong. Like we're already at that stage. You either hire more testers or you try and stop issues from happening, deal with the bigger quality sort of issues. More sort of broad lessons learned there. If all your problems are stemming from a root cause unrelated to your testing strategy, no amount of automated tests is going to fix that. You cannot measure the effectiveness of quality engineers by GitHub commits. I don't even want to get into that. Like, I can't believe that ever became a thing. I mean, if you measured a developer by GitHub commits, I think that would be bad. I mean, maybe if 6 months gone by and they haven't done any commits, that's then slightly concerning, I guess, because what have they been doing for 6 months? But a tester whose job shouldn't necessarily be just writing automated tests, depending on what you've hired them for, right? Obviously, if you hire an SDET, that's a bit different. But hiring someone to deal with like quality issues and testing in general, and then measuring them by GitHub commits just doesn't make any sense to me. And then poor leadership often gives no room for growth in the realm of quality. And this is, I think, a good leader, if they're managing sort of testers and developers and so on and so forth, they have to have a vague understanding about what the purpose is of those different departments and what purpose they serve. Like, just so, because it's hard to give someone direction, right, or advice or mentor someone in your team if you don't understand anything about their job. And one of the problems that you have a lot, or I've seen a lot as a quality engineer, is that if people don't understand it, this quite often they've hired quality engineers to basically check a box. They go, oh, we need some quality engineers because that's what people do. And they've done that, and then they don't really know what they want from them. And then they go, oh, well, we'll just write some automated tests or something. So number 2, I'll do a Q&A at the end, by the way. So if anyone's got any, wants to shout at me about any of these opinions, that you can do that at the end, and I'm quite happy to talk about it. So number 2, tester does testing. Manager demands automated tests. There's a common theme here. Tester inherits this problem. Tester then writes automated tests with virtually no idea what they're doing. And automated tests are now flaky, impossible to read, and a nightmare to maintain. So this is one of the biggest problems I've faced with automated testing being owned by the testers generally. Like, when I'm hiring testers, I look for testers that think about things in a different way. I want people to think about things holistically and to be able to understand how quality assurance generally is a proactive approach to things, where quality control is the kind of last ditch effort to make sure we catch those things that we've not managed to weed out with better design principles and so on and so forth. And I've worked a load of places where I've come in and said, well, I know a lot about automation, and they've gone, okay, well, we've got this automation test suite. And I'm like, okay, great, that's a good start. And they go, yeah, it was written by the last QA guy that left. And I'm like, okay, fine. And they show me this thing, and it's just the worst code imaginable, and you can see that they've not abstracted anything, and there's loads of duplicated code, and you just go, how did anyone ever understand how this works? And you can see how it's kind of happened. They've started building stuff. They probably learn it all from YouTube tutorials or whatever, and it's kind of built it. And the issues there are that I'll go on to the next slide. There's probably things here. Testers are not developers. We hire them for a specific purpose, right? Developers write code for a living every day. Testers generally will be looking for new technologies to help them to find issues with code or ways to monitor things in a different way. And knowing how to do some development is a really important skill for a tester, I think, but it's not an absolutely essential skill. You can get by without knowing how to automate anything or anything about development practices. You can do black box testing, and that's a totally valid profession. You can make a whole career out of that. And there's the whole quality side of things as well. You can't have everyone be a developer and a tester and understand sort of quality assurance at a more broad sort of level. Tasking someone with no experience to write mission critical code is not a good business decision. You wouldn't hire someone that knew, as an example, if you hired a product manager and they had a great vision for this new product they wanted to build, you wouldn't then say, right, great, you understand what you want to build, now build it, with no idea how to code. Like, that would be a terrible business decision. And it's always kind of been odd to me that there's such a drive to have people that don't understand coding write code that is validating the really critical code. That's, I don't know. I used to be more on board with it, and the older I've got and the more frameworks I've seen that have just in some dire state, I just thought, this is a terrible idea. Why do people keep doing this? And then, as with everything, there's exceptions to the rule, right? There are some testers out there that do understand development and do know how to build good things, and none want to learn how to write stuff in a decent way. But the majority, in my personal experience, don't do that. They're kind of siloed on their own, just building whatever they want. And at some point, there's this crunch, and then the tests become unmaintainable, and nobody knows how they work. And then that person gets fed up and leaves, and then you basically have to start again, or you spend even longer trying to unpick it all. So I work for a mid-sized sort of e-commerce company. This is kind of in the middle of my automation engineer kind of career. Very heavy on process, quite a big company. So it was probably 2,000 people or something. Really heavy on process. They kind of gone through the startup bit, gone through the small company bit, and they just hit that point where there was a process. Everything was ring fenced, lots of red tape, so on and so forth. Huge amount of knowledge silos. There was a different team for everything. They even split up the front end and back end teams, which is not completely out of the ordinary, but to the point where they didn't really know what each other was doing. There was lots of stuff going on in the back end, and the front end team didn't know about it until a lot later, sort of thing, where there was no sort of synergy between the two. And testing was kind of a bit of an afterthought there. They had a really great test lead, and we had a few engineers. We were all kind of doing automated testing and human testing, but there was this general sort of underlying undertone from the developers and stuff in general, that testing was always we kind of story point load of tickets and stuff, and they go, oh, how long is this going to take to test? And I'm like, we haven't even written the ticket properly. I don't know. How long is a piece of string? And it was never well, let's involve testers in the whole shift left thing, right? Get testers involved as early as possible. That wasn't really a thing there, which made a lot of things very difficult, because then we're trying to write everything after the fact, including automated tests. So the takeaways on automated testing from this place: Automated validation should be written with the same level of care as any other code. One of the problems we had, and because I've always kind of prided myself on, if I'm going to write code, I want the developers to tell me what I'm doing wrong. I would get them to peer review it, because I want to learn how to write better code. And I don't see why, if I'm writing code, it shouldn't be held to the same standard as the developers writing code somewhere else. And that was not the consensus there. And there was a lot of stuff we had that was just bad, and it just used to fall apart all the time. We had a nightmare with flaky tests and so on and so forth, and building stuff on the front end. I'll come back to that. This company comes up a few times. Building an automated test framework is not a task for the inexperienced. Kind of alluded to that already. Like, ultimately, writing automated tests is a skill in itself. I think building a framework from scratch is super dangerous if you don't know what you're doing, because you don't understand why you're doing. You can watch a YouTube tutorial and you can copy what they've said you're doing, but you don't understand the underlying rationale behind why you've done it that way and something. And that means that when you hit bigger problems later down the line, like if you didn't understand anything about parallelizing tests, and you get to a point where your tests take 3 hours to run, for example, and they're like, oh, why don't you parallelize it? And you go, I have no idea what that means, because I just did this from a YouTube tutorial. That then becomes a big problem for you. And you cannot have a bus factor of 1 with your automated validation. So whatever you've created in the sense of automated testing, so one of the problems we had here is that I was the only one that knew how anything worked in terms of the actual framework. So whenever the test bit broke, I had to fix it. I literally had to come in for my day off like a couple of times, because the test would break and they'd go, the release is stuck. Oh my God, what are we going to do? And then I had to come in and fix these automated tests. Bigger question there is, why did my automated tests keep failing? But I'm not going to talk about that. So lessons learned more broadly here. Rollback should be a last resort. This is, not all to do with automated testing, obviously, but the panic used to be like we'd deploy something, it would break something, and they roll it back, and we end up with these stacked up releases, which then becomes so much harder to test. And it's just much more likely that the automated test then will break, because you've got several features going out at once, so on and so forth. It's an absolute nightmare. The more people that work with your test framework, the less of a risk it is. I mean, it's the bus factor thing, right? Which is why I am such an advocate for it not just being the test team that understand it, because there's generally so much scaled down compared to the development teams. Like, half the developers understand what they're doing, right? So that they can help. And testers should have a proper seat at the table. I try to never work for companies now where testers are not treated kind of with equal respect to like the developers and the product managers and so on and so forth, because it is a totally different skill set that you're looking for from testers. And if you don't value that, then you're setting yourself up for failure. Like, if you don't have anyone thinking about stuff at that level, then you're missing a trick. There's a lot of risks and stuff that people don't think about, and that's why testers are that's why it's a valid profession, right? Number 3. So manager hires automation tester even. Automation tester writes end-to-end tests for the front-end application. Oh, this is a good one. Tests take forever to run and only tell you whether something is wrong with the front end. Meanwhile, back-end changes are going untested indefinitely. This was a much bigger problem, I think, sort of like 5-6 years ago, or were the places I worked anyway, because a lot of places hadn't built APIs. It's only more recently that everywhere that I work has got an API or multiple APIs. And there's just there was this fear of testing the back end. And I don't know where it came from. I think it's because if you could see the test running, people were like, oh, well, that's definitely working, rather than getting the outputs in a terminal and going, oh yeah, that looks like it's fine. So understanding mitigation on this one. APIs and backend services are absolutely essential for an application to function these days anyway. We have microservice architecture, which is infinitely complicated. And if you're not testing that stuff and you're just testing the front end, debugging is an absolute minefield, because you could throw a 500 error on the front end, for example. I mean, because that's what people like to do, right? And you go, okay, so this test is broken. And then you say you've got 100 microservices. You go, okay, where do I start digging? You have no idea where to start unless you had very good unit test coverage or integration test coverage or something lower down, and they were also covering the same test. So I always find it kind of a little bit strange when you have these automation testers that are just focused on automating the front end. Testing the back end is faster. It's so much faster. If you test an API, you can cover so many more tests in it's probably a magnitude of 10 or something to test the front end, because everything just it takes slightly longer to render and so on and so forth. Even if you're running headless, it doesn't save you that much time. An API, if it's any good, is going to respond almost instantly, depending on what it's doing, right? You could do some crazy complicated SQL queries or something, and then there's a exception. I'm going to stop undermining my own points in a minute. But for the most part, an API request is going to come back like that. And you can get so much feedback so quickly before you've even built the front end for it, which prevents you having problems there, right? And a front end test suite, whilst nice to have them visually impressive, I totally understand the sentiment there, is not as useful as better coverage in the API. If all of your, I mean, these days, you shouldn't be putting like complicated logic and conditionals in the front end if you can do it in the API, because it's quicker to do it in the API. It's generally better practice, right? Because you want there to be a single source of truth for all of the things that the complicated stuff that your application does, which leaves the front end engineers to just have to like interpret that and display it in a nice way. Like we put much more focus and emphasis on the visually impressive element of the front end applications now, like with React, for example. Like you can build some really impressive front ends that are really slick. You don't want that to also have to be like doing lots of complicated logic with stuff that you could have done in a more performant language somewhere else. The same company again, so some of these points are the same as before, but the focus was on front end testing, and we had all of this stuff happening in the front end, and it was really slow. And they built an API as part of a merger they were doing when I was there, and I was like, well, I'm going to test the API because I think that's going to be better. And what we started doing was using the API to set up the tests. So this is kind of a paradigm I've kept since then, in that like there's a specific thing you want to test in the front end. Well, don't load up the front end, log into the front end, go through several screens in the front end, and then test the thing you want to test, and then finish logging out or whatever in the front end. Don't do that, because that's going to take you a long time when you could authenticate the entire session, for example, in the API, and then set it up. In fact, better still, you can set it up. I put kind of API tests in SQL are generally avoided, which was a terrible thing there. And you could set it all up with the database. And then you don't even have to do that much with the API. It's infinitely faster to just seed the database with the data that you're going to need. Use the API to authenticate, and then load up the front end, test the one thing you want, and then tear down with the API again, or the database, whatever. You don't even need to do a teardown half the time if you're going to just reset the database anyway. And the front end test like broke all the time, more flaky, and there was just this kind of like, it was just like normal for front end tests to fail. And it's I come back to this point in a little while, but just this idea that you are okay with the test failing like consistently, because then people just don't trust the tests. So lessons learned more broadly, API tests are infinitely faster and more reliable than front end tests. I haven't gone through this already, have I? No. Okay, cool. Data setup using the database is much more reliable than hard-coded values for tests. We had this real big issue where we would, because it was an e-commerce company, and the data we were using in dev, for example, when we were doing our testing, it would be using a database, and you'd have a product catalog, and then it would tell you what the quantity of these products was. And when I first started working there, the way it did it is it had a specific product it was looking up for this one test. There was like literally a function that said, look up this particular thing. And it went and got it from the database or whatever, and just went, okay, yeah, I'm going to use this thing, and then went and checked out. And it meant that after it ran like 100 times, it ran out of stock, and then just the test started failing because it ran out of stock. I'm like, why would we do that? And like, you can easily just increase the stock, or the way I coded it in the end is that it did a SQL query to find a random item, didn't matter what item it was, and then just add 100 stock to it. So it never failed because it always got stock, and it's always a completely different item. So there was never any way it could be like an item we'd hard coded, and then that could, you know, be deleted in the future, and then it wouldn't work anymore. It always just went, give me the entire product catalog, find a random one, so on and so forth. And not enough consideration is given to testability when designing applications. So this is a massive problem in lots of places. It's getting better from what I've seen, but testability is not something that people think of up front generally. Because I mean, again, it's the same problem you have with unit testing when you first start out, right? And people go, oh, well, let's just get it to work first, and then unit testing becomes tech debt. And they go, oh, well, we'll do that later. And it's kind of the same thing with testability. The problem with testability is that unit tests you can add whenever. They're just a bit of a slog. Testability, if you haven't inbuilt that into your application, that's really hard to retrofit. Like if it works in a certain way, like I have a big problem with like queuing systems and stuff. Like if you're testing directly with a queuing system, that's really hard. How do you do that without just like loads of waits? And just, you know, because you've got to wait for the queue to come back, or messages to come back. And like that sort of thing had just not been considered. And I'm like, well, there needs to be an easier way for us to get this sort of information. And yeah, that's just a huge issue that I've seen. Number 4, automated tests provide feedback to developers. Managers like seeing all of the green ticks. More effort is spent creating more simplistic tests, and complex value add or deep tests are discarded. So yeah, this is kind of along the same line of having like managers that are kind of detached from the idea of what's the point of testing, where they go, well, it's great if we can see that everything's green. Whereas like when you think about it, like the purpose of testing is to find bugs. You want to find the bugs before it goes out to production, right? So tests should always have a purpose. We write tests to discover bugs. If your tests are not finding bugs, what did you make them for? I've caveated that myself here, but like I understand that there is an element of like we want to be confident the platform works, but if you're doing that before you've covered all of the things that your test team think are the high risk areas or things that are critical, we can't have this go wrong. That's really risky. You're risking something by automating in the first place, and then risking it even further by not even automating the things that you're actually concerned about. You're automating the things that you think are going to give you a nice amount of coverage or so on and so forth. So I think here, then this is a really difficult thing, right? Like educating the management on the useful metrics discovered from testing. I've worked a lot of places where they're like, oh, we want you to measure how good the testing is. And I'm like, okay, what do you mean by that? And like a lot of the time it's like, we want to know how many tests have been run. I'm like, that's not a useful metric. That's just incentivizing people writing arbitrary tests. That's not a good thing. So instead of we tested 300 things and everything was fine, explain that we tested 3 things and we prevented 3 bugs hitting production. That is a 100% success rate for tests, right? Rather than we tested 300 things and they discovered nothing, or they prove that the things that we did test work fine. And then if something goes wrong in production, obviously you're going to get grilled because they're going to go, why didn't you find this thing? How did you do 300 things and not find the one thing that went wrong? So that's a much more effective measure of success. And it's still a way that gives management or people that are detached a way of going, okay, yeah, that makes sense to me. I can report on that metric and people will understand it because it still seems like a success, right? So as an NLP startup I worked for, this was a proper startup. So they did not have a test or QA strategy. That I was the first senior member of the test team. They used ephemeral environments. That was like the second place I'd used ephemeral environments, but the first time it had been used like really effectively. And at the time I was like this is the best thing ever. I don't know if people have heard of it under different terms. So sometimes they're called feature environments or like Phoenix environments or something, but like that was a really cool thing to kind of play with. And they had an abundance of 500 error codes. They did not use HTTP error codes properly. Everything was a 500. He used to come back and say, oops, something went wrong, which was awful for automating anything because you would be expecting like certain errors. So it was weird how many errors we picked up when we first started automating stuff, because we were going, okay, I tried to log in, I used the wrong password and I expected 401 and it was like, you got a 500. And I'm like, why is that a thing? So takeaways and automated testing from this place. The automated tests were considered the end goal of testing. Like when I came in, the VP of engineering at the time was like, are you gonna, so if you started automating any tests yet? And I'm like, no, I haven't really tested that much yet. We've like come up with a big test plan and we're going to go through and like methodically go through all of the different bits of the platform to understand what the current state is before we then start automating things. Like I can't automate things before I even understand what it is I'm testing. And ultimately I wouldn't even know if I was automating the right things if I haven't got some idea of like a heat map of where the risks are and what the areas of the platform that need more testing are. API tests mean virtually nothing to those outside of engineering roles. And this is like still a common thing now. I think unless you work with APIs a lot, people don't really understand what APIs are. They can see a front end, and it's the same thing that we used to have as a bigger problem in testing, is that you can see the front end and it's visually pleasing and you go, yes, I understand this because it's something I can absorb with my eyes. Whereas you go an API and then you've got to have an API key and people go, what am I supposed to put in here? And sure, you've got API docs a lot of the time, sometimes if it's a good developer. But people are ultimately like scared of the API. They don't want to learn about that because it's like they have this thing like, that's an engineering thing. And in real terms, like more people are absorbing APIs and integrating with APIs now than they used to. So it should be more commonplace, but I've found that it's generally not. So API tests, when you go, the API is working fine, they go, yeah, but what about the front end? Okay. Well, the front end does what the API tells it to. So yeah, that's an interesting one for me. Automated tests were a means to an end rather than a tool to be utilized to improve the quality of the application. So yeah, ultimately they wanted automated tests because they thought better coverage was good for the platform, rather than going, we want you to introduce automated tests because we want the platform to be better. They just wanted to. It's almost like we want to prove that our platform's already good by having lots of green tests. And you go, well, that's not how it works. You want to catch the things that are bad now so that somebody else doesn't find them later. So lessons learned here. More broadly, not raising bugs does not mean that they don't exist. So me and the junior tester at the time that I was kind of working with, he'd kind of been left to his own devices for 6 months, not having any experience in QA generally. And we came up with this test plan and said, like, okay, we're going to go through all of this stuff. And we found like something like 200 bugs in the first like 2 weeks. I remember the VP of engineering being like, why are all these bugs here? Like, what happened? And I was like, well, actually, nobody's been raising bugs, basically. So all of these bugs have been here for God knows how long, and nobody's been paying attention to them. Everyone's been kind of like just working around them. Everything throwing a 500 makes debugging a nightmare. I kind of already mentioned this a little bit, but like it's worryingly common practice, I think, for everything to just be a 500 and people not to use the right error codes and stuff. Because I mean, I kind of understand the rationale. Like, if something's errored, at least I'll show them an error. But that's not that helpful. If you're really debugging stuff and really looking for problems, you just make it slightly more difficult to then understand where the root of the problem is. And doing the right thing is not always on everyone's agenda. I used to have this deluded idea. There's the delusion on my part there of, you know, everyone wanting to do right by the company they're working for, sort of thing. And again, the kind of an age thing comes with experience, right? That you understand that actually this person has their own agenda and they want to hit their own OKRs, and they're not even slightly interested in what I'm trying to do. They don't want quality for the platform. They just want to tick some boxes so that their manager gives them promotion or so on and so forth, which can make what we do super difficult, right? Number 5, I promise these are nearly over. I'm conscious that I'm just talking at a screen at the moment. I have no idea how anyone's, if anyone's even still here, actually. So number 5, if tests are flaky or nobody has had time to fix them, people ignore the red tests and say things like, you know, oh, that always fails, I'll just rerun it. And now nobody trusts the tests. This is a huge problem. Like, and one of the reasons that I think that, you know, some care has to be taken with automated testing, and like when you introduce it and who introduced it and who's responsible for maintaining it. So like, don't write tests you can't possibly maintain. If you've got, in like the scenarios I've kind of alluded to earlier, where you've got a single tester for 5 to 8 developers or something, and they are the only person writing those automated validation tests, don't write hundreds of tests, because you're going to have to maintain them by yourself on top of doing whatever else you're supposed to be doing in whatever manifestation of the quality and test role you've got. And that's just unattainable. I've worked several places where my entire being has just become, I write automated tests and fix them. And then you can't even maintain that, because then what happens is the tests get bigger and bigger and bigger, because you still have to introduce new stuff, and you're kind of trying to do it retrospectively. And then I've got to fix this thing. And all of a sudden I've now got a backlog of things that are broken. I'm not actually verifying changes in the first place anymore. And I'm just literally dedicated my entire time at work to just trying to play catch up and fix things. So scalability is like a big thing for me. There is no 85% pass rate that's acceptable in testing. There was a company I used to work for that did this, and I couldn't get on board with it at all. Like, if you've got an 85% pass rate that's acceptable, that means that 15% of your tests don't matter. And then it's like, well, who decides which of those tests don't matter? Like, that was kind of an arbitrary, oh, well, if we get 85%, that's fine. I'm like, but that means you don't care which of your tests pass, as long as most of them pass, which just is, that's not the purpose, right? Like, you want to, it doesn't matter if people go, okay, that's a bug, we should fix that. Like, fine, come up with a strategy, fix it, get rid of the test for the time being, because that is ultimately now just going to throw up a false positive if you've already decided you're going to deal with it in one way or another, unless you're hot fixing it and you're going to fix it there and then, fine. But ultimately, like, leaving that there, just failing all the time, is just decreasing people's confidence in those tests, because they start getting this idea that a red test isn't really that important, because they go, oh, well, we ignored that one the other day, so I guess we can ignore this one as well. And so remember, the goal is to make testing and therefore feedback faster at a cost, kind of the risk thing I mentioned earlier, not to add more confusion to the mix. If you've got developers then questioning whether it's okay that a test has failed because one failed the other day or so on and so forth, you've made that feedback loop really confusing and not faster, which is what we're supposed to be doing. This company again, e-commerce maybe that's the issue there. So less than 100% pass rate, not acceptable in my opinion. And flaky tests are a surefire way to the death of your automated validation. Like, the front-end tests are like notorious for this, right? And like half the time the solution is, well, we'll just extend the wait. And I think testability is like a big thing here, and one of the things that doesn't get enough attention. So people are quite quick to say, oh, well, we'll just make that wait a little bit longer, because that sometimes takes a little bit longer to come back and render. And you go, well, why aren't we investigating the reason it's taking to like render really slowly? Like, that's not good. If I was a person and it took 45 seconds for me to be able to see something, I'd lose patience with that website and I would give up. Well, a lot of the time anyway. I mean, it depends what I'm trying to do. If I'm trying to do my tax or something, I'd probably, wait, because you accept that that's a thing from HMRC. Lessons learned or run. No, I've already done them. I guess it's the same company again. Sorry. Number 6. So last one of the spiral series. Automation testers exist. Developers tend to rely on the testers for their automated coverage, and developer-led testing then declines. Mass panic ensues when someone eventually looks at the unit test coverage. This is not just a problem with automated testing. This is a problem with testing in general and kind of attitudes towards it. But like, you need someone, if not everyone, championing quality across your company. You can't rely on the few to remedy every mistake and assumption made, because it won't scale. You can never have one person that has that much influence over everyone, and you absolutely cannot have one person, depending on the size of your company, like checking that nothing is wrong, or that all the serious stuff isn't wrong. And you cannot possibly hope to scale a quality or test team that serves to undertake all of the validation and verification that nobody else wants to do. Like, there's always some resistance when you go from like a scrappy startup to a smaller company. There's some resistance depending on the engineers you've got, but like a lot of the time, there's a lot of freedom kind of given to, like, we need to put a POC together and we want to then make it an MVP, and we'll worry about unit test coverage later. And you hire a QA and they go, what's your unit test coverage like? And they go, oh, we don't do unit tests. You go, right, well, you need to do unit tests, because otherwise what I'm doing is really, really difficult, because all of the really simple stuff that I don't want to have to be bug finding, we're not finding. It's like, so that's why unit test is really, unit test coverage is important, because one, that's fast feedback to a developer when they're building on something, especially if you've got more than one developer working on it, right? But also, you waste the time of the test team, who are there to find complicated stuff, if you're not finding the really simple stuff, because then they spend all of their time finding the simple stuff, which means the difficult stuff ends up, or hidden stuff ends up getting out anyway, because there's not an infinite amount of time in the day. And let's face it, the first thing to go is the test window. Well, that's a bit facetious maybe, but so there was a big insurance company I used to work for. They did not have any automated validation at all. Which is where my kind of like hunger for automated testing came initially, and why I was kind of threw myself into it so much. They didn't have any APIs. Bureaucracy was a massive problem there. Like, there had to be reports for everything. You had to report daily with all of the stakeholders involved in projects and so on and so forth. It was just a huge amount of planning and paperwork and stuff, and the test team were the last people to know about anything. Takeaways on automated testing from a place with no automated testing: that puts a hell of a lot of strain on your test team, because everything has to be verified manually. And it was this particular company was waterfall, so everything would be planned almost like months in advance of it being delivered, and then the last thing that happened would be like, throw over the fence to the test team, nothing works, start again, and this test window would be the only window you have left, and it would just be getting smaller and smaller, and you're going, oh my god, we've tested like 30% of everything. And having no automated testing slows you down a lot. Like, I'm pretty sure everyone accepts that automated tests are fast. That is the faster way to go. And we accept that risk, right? We accept that they're not human beings and they don't do what human beings do, but they're valid. It makes sense to do it, because that's how you move faster. It's a worthwhile risk. Lessons learned here: prevention of bugs is often better than discovery after the fact. And there's this is like a wider thing in testing QA. I keep saying testing QA because I think there was this point where testing, because of the shift left movement, and like, well, let's get testers involved in the design phase, then it became merged with the idea of quality assurance from like manufacturing and stuff. And it totally makes sense, but I do like to try and differentiate between testing, because that's quality control, and especially in software, it's a really complicated role, because there's so many different tech stacks, so many tools out there, and like trying to keep up to date with the most recent methodologies and technologies is a whole job in itself. Like, quality assurance, you need people that are thinking about that sort of thing, but testing is a totally different thing. Nobody reads test reports. Like, found that out pretty early. Like, no one cared what we were writing in test reports, unless you've gone, this thing is very broken, then they go, why is that broken? But if it says this was fine and we found some really interesting defects and they fixed them, no one cares. Grading testers on the amount of bugs found is very toxic and makes everyone very unhappy. And this is kind of one of the things I was talking about earlier around like measuring test metrics, like one of the things like, oh, how many tests has everyone run? Like, that's not a good thing to measure. That doesn't really mean anything. That's just going to make people feel sad. How many bugs did this tester find? Well, that's actually completely dependent on what they were testing and who they were testing with and what developer wrote the code or how complicated it was, so on and so forth, or whether they were inclined to actually find bugs, right? And this is a second company I worked for, this different e-commerce company. So I worked for two. This one was actually pretty solid in terms of like their setup, because their CI/CD was amazing. Like they had a really good CI/CD pipeline. The caveat there is that it was an internal application, so they didn't have to worry about delivering this to clients and then clients going, oh my god, you've broken this thing. So if they broke something, they'd be like, it's fine, we'll just hot fix it, it's fine, which is great. Because fixing forward, after the experience I'd had with like stacked up rollbacks and releases before, was like a breath of fresh air. Like I was going, oh my god, this is great, they're just fixing everything forward. And because they had this CD system, it was like tiny changes going in, which meant you'd see something would break and then you go, oh, that's broken, well, it was that thing that we just put in. So that it's super easy to find out what's wrong with it, right? Which alleviates some of the pressure on testing, because you know that you've got that coverage there, and like kind of like that, you know, it's a little less pressure to get stuff out, especially if it is an internal application sort of thing. Feature flags, like this is the first time I was introduced to feature flags, and I know I talked earlier about ephemeral environments being a really useful thing, but feature flags, like and now in my career, like feature flags are my favorite thing ever. Like I'm like, I can test 7 different things in isolation in the same environment, and that means we don't need so many environments, because setting up ephemeral environments, especially in like a complicated architecture, that's a lot of effort. And I've also worked at a company where like we used feature flags in the automated tests, and one of the problems that you have with automated tests when you build them right for new features is, well, you can't merge that into the bulk of your automated test suite, because those tests are always going to fail until that thing is properly delivered. But if you're doing it behind a feature flag, you can just put it behind a feature flag, say, oh, for these tests, use this feature flag. And it doesn't matter if like some of them are red, because people go, well, that's not a feature that's out yet. So it doesn't run when you're deploying to production, for example. But when you're running in development, you can have those tests run, and the developers can get feedback on how close that feature is to passing, if you're getting like red-green tests, obviously. But also the fact that just because you're still developing a feature and haven't put it live yet doesn't mean that you can't regress on that thing that you haven't even delivered yet. One of the problems that you have, right, with bigger features is if you're not putting out little bits at a time and then regression testing those things, you can break something that you wrote 3 months ago and haven't released yet, and then put it out live, and you go, oh my god, how do we miss that? And it's like, well, we didn't, but then we broke it, and then we didn't check that we not broken it. And they had a total lack of test leadership, so there wasn't really any sort of coordination there in terms of like what the test team should be doing. Paul, I'm super aware that you write in Java, and this is just my personal opinion on Java, but where possible, Java should be avoided for automated validation. The worst test framework I've ever worked with was written in Java, and the biggest problem I have with it is that I think it's people's go-to. Like when they first learn about automated testing, for some reason, people go to Java. It's fine. There's nothing wrong with the language in itself. I do think like when people write in C# or Java or Go for automated tests, that's a heavyweight language to use for something that is ultimately just doing input and output checking. There's caveats, as there always is. If you're doing something like that needs to be a really performant test suite, fine, use one of the more heavyweight languages. But there's so many like easy to use frameworks in Python and JavaScript or whatever that are so much easier to spin up. It's easier to read for people, especially the people that don't code. It's easy for them to pick up because it's more human readable sort of thing. But one of the biggest problems I have with it is that people often use Java, even though that's not the native language of the company. So like development teams. So the company, this particular company, it was a C# stack using .NET Core. And all of their automation in Java. So the developers wanted nothing to do with it. And it was one of these cases where someone had spun up this automation framework on the fly kind of thing with not really much idea of what they were doing, and kind of hacked it together as they were going along. And I was like reading it going, what have they done here? And then I was like going to the developers, like, do you understand this? And they're like, no, I don't do Java. I'm like, great. So the lesson there, I think, I mean, I'm just being slightly facetious and saying like you should avoid Java, full stop. If your tech stack is Java, use Java. If it's not, don't just write something in Java because there's lots of tutorials out there. Like spend the time really learning about what you're doing, and rather than just following a tutorial. I kind of said earlier, right, building a framework is not a easy thing that you should just do based on someone else's advice. You need to understand it so that you don't dig a hole for yourself that you're going to deal with later, or someone else is going to have to deal with later. And CI/CD only works when your testing coverage is sufficient or your application is non-client facing. So where am I going with this? So CI/CD, if you've got a client facing application, if your test coverage isn't really, really good, you don't want to be doing CI/CD, because there's no way like your testers are going to be able to like get to stuff in time, because things go out too fast. You've written a thing, it passes the automated test, it goes out, it automatically deploys. You could do it so that you did that behind a feature flag, right? And then it becomes okay, because you can kind of like, well, we can just test it wherever, knowing that it's hidden away, which is a different strategy, and that's totally valid as well. But generally speaking, people don't give it that much thought, and the test coverage just needs to be really good. And it doesn't matter if you miss something every now and again, right? Because if you're doing CI/CD, something goes out, it's normally a minor thing. You make sure your critical stuff's covered, your high risk stuff is covered, so that you're getting that feedback and it doesn't deploy if something goes wrong. And then when it does, high chances are it's one of the like less severe things that have broken in production, and we can fix forward fairly easily. Or you go, actually, it's not much of a problem, we'll do it in the next sprint, whatever. Lessons learned here. So someone has to set the quality and testing strategy that understands the craft. I mean, that's actually fairly self-explanatory. I don't feel like I need to really elaborate on that. And feature flags, you might have got this kind of impression from what I was just saying, but in my opinion, feature flags are one of the most powerful tools out there in terms of like how we do deployments and releases, and how we can safeguard against the ever-shifting kind of like push towards more automated testing, because I think that's inevitable, right? We are going to get to a point where automated testing is the bulk of our testing, and the testers are more involved with the design and more spending time really digging for complicated issues and trying to catch those things, knowing that there is a huge amount of like automated validation to catch the stuff that they don't want to waste their time on because there's less value in it. Automated tooling in the community. So why this is bad news for all of us. So testing and quality or quality assurance are poorly defined and widely misunderstood, particularly in the tech industry. This is not a problem that's going away anytime soon, I don't think, based on the sort of interviews I've had and like conversations I've had with other sort of people in the testing community. As I mentioned, like right at the beginning, like we're totally divided on automated tooling and the terminology surrounding like, can you call it automated testing? No, you should all call it automated checking. Like I understand the sentiment there, and I personally am of the opinion that I think it's gone too far, and you know that's a pointless argument to have. Like who are we really helping? Like half the time it's just testers arguing with testers, which is not doing anyone any good, and it makes it harder for us to move forward as a craft, right? Like it's a serious craft, and there's a lot of skilled people in it. So if we're just arguing amongst ourselves about terminologies and stuff, like that's just making us look silly to everyone else. Is automated testing even testing? Not in my opinion. But it serves a similar purpose. As I say, like you're doing the validation stuff, you're taking a lot of the simple stuff and giving testers or empowering testers to spend more time doing the stuff that is only a human that can do, that sort of thing. The majority of serious testers are aware of the concept of context-driven testing, which means that arguing about the way in which we're doing testing is rarely going to align if we're doing it properly, right? Because I don't think I could apply the same testing strategy to any two jobs that I've had, because the tech stack is different, the way that they do deployments is different, the context of the company is different, right? So you go, okay, well, how am I going to do this? So let's learn a bit about the product. Okay, that's fine. So if you've got a microservice architecture, that requires a different test strategy. If you want to do CI/CD, that's a different thing. Some people don't want to do that. If you worked building rockets, for example, you've got like one chance to get that rocket into space, for example. You want to test as much as possible and really take your time doing it. You don't want to like rush that. So there's a lot of this, well, you should be doing testing this way, you should be doing it this way, and this is how you should do automated testing. Like you can only really have those opinions if you work in that environment, if you're in that scenario. So you can't like retrofit your own testing strategy to someone else's situation without really understanding where they're coming from. There's a multitude of varying job roles, making it hard to hire or even understand what the right hire looks like. So when we've got like quality assurance engineer, like tester, test analyst, software developer and test, and like these are so merged together they don't even make any sense, half of them, anymore, because a software developer and test half the time might not even actually be a software developer. It might be a tester that just happens to do automated testing, and they've had a previous automation tester role. And I work with a guy at the moment who used to be an SDET, and he's one of the biggest allies we have from the quality side of things, because he just gets testing, he understands it, and he's like, oh yeah, sure, I can do that. And he's a gifted developer, which is really, really helpful. But if you've got someone who only has ever written automated tests and possibly has only ever written them the way that they want to write them, that's much harder to get to work in a team that's looking at stuff in a different way. So if you've got a test team and you've got an SDET that's done, subpar development standard test frameworks, that's a difficult match to make, in my opinion. And the term manual testing, people find very triggering. Sometimes they're actually so, but nonetheless, this is one I kind of agree with. And like, I see a lot of people kind of like parroting arguments from like some of the more bigger names in software testing, without really understanding why they're arguing about it. But like, manual testing is just reinforcing that idea that like at some point we're going to automate it. Oh, well, that's manual at the moment, we'll automate that later. And it's not. Like, testing is its own thing in its own right. And automated testing, fine, we can call it that, but there needs to be this like understanding that automated testing is just that validation side of things. And calling stuff manual testing just reinforces that opinion that they're virtually the same thing, I think. Other lessons learned. So there's another couple of companies that I work for. I thought I'd just throw these in there just to give a little bit more context about where I'm coming from, lessons that I might have learned, so on and so forth. So it was an ad tech startup I worked at. This was, again, like proper scrappy startup. We didn't have that many people there. Super agile. This was the first time I worked in agile, coming from a waterfall company. So that was a massive culture shock for me. Very little tester involvement in the automated validation. They basically came up with some tests in Cucumber, and the developers wrote it all, which is, fine. So that makes sense, as long as it's kind of like a relationship you keep going. They also had good CI/CD. This first time I worked with GitLab, where you had all of the tests broken down into different sections, and it's like, that's a really useful way to get the feedback, rather than just having one test suite that runs and you get 100 ticks or crosses. It was broken down into sections, which meant you could easily see if there was a problem with this particular service or this feature. Takeaways on automated testing. So quality engineers have a different perspective on automated tests. This is a big point for me, like in the way that I do things now, is that if you have someone that's a really good developer, they can write good tests, but they don't good tests in the sense that they'll write good code that is testing something. That doesn't mean that they're writing the right tests. You need to like have two people working on that, I think. I mean, you're going to get the odd case where someone is a tester and they've learned how to develop and they can do those sort of things. But I'm still of the opinion that at some point you're going to cross over to the other side, and you become more developer than tester, because that's what you spend your life doing. If you're not constantly challenging yourself with like, oh, how can I get better at testing? You kind of lose sight of that a little bit. So having those two different perspectives, like, this is what's possible, this is how we can do it, this is how we can test these things, and this is how we can integrate with the tests we've already got, versus what about this? How do we do this? Have we thought about this? This is a big risk. Like, what can we do there? Those two things are both really valuable, and I think neither of them should ever go away. Automated tests should always speed up your deliveries. Like, again, this is one of those things where people go, oh, I'm going to write some automated tests, I'm going to automate everything. And it actually becomes slower, because if you've got, for example, situations like I've been in the past, where the strategy was to write the automated test before we delivered something, and you've got one person doing that, and that's to actually code all of the automated tests. If you don't have the kind of like abstracted functions you can reuse and everything there initially, building extra automated tests takes longer than testing something itself generally. I mean, don't know how fast you can code, I can't type that fast. And there's like problem solving you've got to do throughout, because you actually have to test the thing first, kind of, to then work out exactly what the inputs and outputs need to be. And if you've got to wait for that before you deliver, then you've actually slowed down your process by not doing that. So I don't know. Ultimately, the end goal should be like, if you look at it and go, okay, over 6 months, have we sped up or have we slowed down? If it's slowed down, is that a good thing? Should we be doing it differently? Is this actually adding any value? And this kind of comes back to like making sure you're automating the right things. Don't automate everything. Automate the things that matter. Target your kind of regression tests. You would as a human being, right? You wouldn't go, I'm going to test everything. You go, right, what are the things I think are high risk? I'll test those things. Other lessons learned: releases don't have to be a big deal. This is the first time I did like CI/CD, and I was like, oh my god, this is nice that everyone's just like going, oh, we'll just put it out, it'll be fine. Testers have valuable input into what we automate. I've kind of already just said that. And testers have valuable input into process and strategy. That's something that was super new to me at the time, and now it's like 90% of what I do. Because we've got this way of looking at things and going, well, what about this? And like, have we thought about doing things a different way? And actually that skill set, and I think this is another reason that testing and quality assurance kind of get blended together in a lot of places, is because it's a similar mindset. It's that holistic way of going, I'm going to take a step back, look at what we're doing, and then understand whether that is fit for purpose or not. This is the last one. Well, second to last, penultimate. There's a data collaboration startup I worked at. Startup kind of becoming a scale up, I guess. And generally speaking, they had a lot of really, really smart engineers at this place, and the engineers owned the automated tests completely. We did have a test owned one, but it's kind of fallen apart. It's written in Selenium. It was a bit out of date. There was a lack of maturity in the release process. They've kind of gone from a very CI/CD thing to gradually like manually deployed releases, which was odd to me. But and that was difficult. That made it created a lot of confusion around when we released something. And we had so much good infrastructure around CI that was like not being utilized properly. The testing strategy there was really ad hoc. And this is one of the big takeaways for me, though, was that the testers curated the automated validation. So the idea was that when we did planning of like features or epics, the testers would kind of like brainstorm with the developers and go, okay, well, I think we should, this is something I think we should add an automated test for. Like, we'll test it, fine, but like we want to add some automated testing so that we know that going forward, that doesn't break. Which was a nice way to do it, because then you've got the developers who write code for a living, writing the test. They're written in a way that developers understand. It's never going to go away because you're always going to keep the same tech stack, rather than relying on what is happening.
Oh, we just I'm actually just checking to see if there's, I'll let you know, there's like about I want to reserve like 5 minutes for a couple of questions that are coming up on the side.
Cool. And, I don't know how long.
We're coming up right up on the hour. Go ahead.
Okay.
Go ahead, Lou.
Cool. I'll just run through this. I'll have a bit more coffee and then I can speed up. Automated tests using feature flag are the way to go. Already alluded to that earlier. Best way to scale automated validation is to have it owned by the developers, in my opinion. Like, I think we're going in a way where quality coaching is more of a thing, and there is more of a emphasis on the quality side of things and the more holistics of like how can we do more quality assurance as opposed to just quality control. And I think having the people that write code for a living do that thing makes more sense, especially if you're scaling. I think you get to a certain point of scale where it almost doesn't matter. You can kind of employ whoever you want, and as long as you've got someone doing it, it's probably okay because you've got enough people around there that there's always going to be support. But particularly in smaller companies, this is really, really important. Lessons learned: testers have to be able to command respect and able to dictate what tests should be automated. Like, you can't just go in and tell someone how to do their job. Like, people don't like that. So one of the things I found is that without me knowing how the tests work, like the automated tests, and being able to contribute in some way, there's generally a reluctance to like accept your opinion is valid. So I think this is kind of what I was alluding to earlier. Like, knowing how to code and understanding code is still important. That's an important skill for a tester, depending on what you're doing, right? If you don't understand that, you are going to struggle a little bit with telling developers how they should be writing their automated tests. Not having a clear test strategy creates a negative reputation for the test team. I mean, that should be fairly obvious, right? But I think that people overlook it sometimes. Like, if your test team are going, oh, well, we don't really know what we're doing, then shockingly, people don't trust them. I know how good your tests are, a poor release cycle will still cause huge problems. And what about now? So now at Silvera. So I started at Silvera like a year ago, just over a year ago. And I was the first quality person in there. We've got an environment where, I mean, we do it in a different way per team, right? I don't like super intense process, which is like really rigid and say you have to do it this way. It's all quite high level. Like, we've got an end goal. This is what we want to achieve. But the thing here is like the quality engineers and developers collaborate on how we do our automated validation. That's the core thing. It has to be a collaboration. It's got to be a two-way thing. And so the testers that we've got do contribute in some way, even if it's a really small way, to the automated validation, but the developers own the majority of it because it's their realm, like it's development. And we've got other things that we're trying to do at a higher level. Quality engineers are not responsible for testing every change. Maybe a slightly controversial thing, but like ultimately that just doesn't scale. You can't have one person testing 8 people's changes. So there's this kind of like coaching element here. And one of the things that one of my team challenged me on when their first day was like, okay, that's a cool strategy, but like, how do you know they're testing properly? And I was like, that's such a good point. So like one of the things he's been working on is like building out sort of a testing framework so that it's easier for people that don't understand testing. So like kind of one of these processes where like, if you don't know better, follow this. If you do know better, fine, do it your way. Quality is not limited to engineering. I don't know why this is always a thing, but QA, quality testing, it's always limited to engineering. It's not at Silvera. We've made it more of a broad thing because there's other departments where the same paradigms we use in engineering are still totally relevant. We've got other people coding that aren't in engineering. We're like, well, they should be doing the same things as us. They should still be tested and they should still have the same quality assurance considerations when they're building stuff. Like, let's make sure that designs are properly considered, so on and so forth. We value the input of quality engineers as things are being designed, not just after they've been implemented. Again, kind of touched on this earlier. Like, we don't want stuff being thrown over the fence to QA and them, then having to discover things and work out how it works too late in the day. Like, if we can fix things before they even become a problem, let's do that. There is no one-size-fits-all approach to quality or testing. Again, this is like the kind of like, we've got a high level objective, and how you do that in your team is kind of down to like the people that are in your team and how they work. And as the teams change, I expect those things to change, because that's a human way to do it, right? You can't just assume everyone's going to be exactly the same, just assimilate whatever process you enforce on them. And systemic issues are treated with the same level of seriousness as defects in code. So if we come up with something and we go, well, this is actually a really big problem, this root cause that's nothing to do with engineering, like, well, we're gonna go investigate that and deal with it, because just because it's not a bug in the same sense that we're used to doesn't mean that that's not actually contributing to the overall quality or lack thereof. So yeah, that's it. This is Silvera. Go check us out, basically. We don't have any QA jobs at the moment, but watch this space. Yeah, that's me.
Great, Lou. I think we got like I'm going to reserve just a couple minutes, and I think we got like maybe one question. I've been monitoring the discussion that's been going on over here between basically it's Olga and Fedor over here, and they actually bring up an interesting point about unit testing. Is that is there unit testing is generally reserved for developers, and you did mention that we are both with developers. We in QA, we are developers. We should be following the same things, but you did say that when we're looking to hire people, we're looking for a different skill set for SDATs than we are for developers. So let me ask you this: what is your idea of what is a unit test in test automation? As versus a unit test, versus what a developer might use for creating an application.
I don't think there should be a difference. A unit test is the lowest level test you can have, right? If you're building functions in your automated test framework, those things should be validated to the same degree that we do testing. I mean, that's my opinion anyway. Like, I still maintain that whatever code we're writing, regardless of whether you're writing test code or application code, you should hold to the same standard, especially considering that your automation tests are going to validate whether or not the application code is doing the right thing. So they've built their own tests to do that. We're now building other tests to validate it. It's like, we're at a higher level. We need to know, it's just come up before, like, because a lot of people don't write unit tests for their automated test frameworks, right? But there's functions in there. Someone can make a mistake. It's still written by human beings. Like, that's just as valid in my opinion. I think it's something that doesn't get enough attention, but
that's good.
Yeah.
In my experience, what I generally do is I do have a script that will automatically kick off as soon as I push something into the Git repository. And then there's one script that I write, which basically tests all the little functionalities, the customizations that I have in the framework. And it goes through and it's basically, it's generally not an end-to-end test, but it basically touches everything that might be something special I wrote to customize that. And that's what I kind of view as my unit test for my framework. And then everything else is just regression testing or automation testing on that. I would say we kind of ran long. There are a lot of discussions over here, and everyone's kind of answering their own questions with stuff over there. So we got a great bunch of people doing that. So I'm going to say at this point, Lou, it was great having you on as a speaker. I'd love to invite you back sometime and discuss some other stuff, because especially with parallelization, I love trying to getting scripts to run concurrently at the same time so we can get our results faster. we could talk for half an hour on that alone. So, but again, thank you, Lou. I'm going to go check out some more stuff on things that you got up there on LinkedIn. Do check out Lou's his stuff, his company out there. Uh, and I want to say cheers. Thank you, Lou, for stopping by.
Thanks.
All right. We're going on to our second portion here. Now, here's something kind of new for everybody out here. And I think this is going to be a little bit of fun and maybe a little bit scary for our next speaker. So we've got a little surprise going on here. So Artem, don't worry about it. Everything's going to be fine. I've actually got you on here for basically for technical assistance if anything goes a little weird or awry. But I'm going to basically tell you, we actually had our other speaker, our second speaker, drop out at the last moment. So what I want to do for the second hour is that kind of talk about and actually demonstrate the what we call codeless test automation. And I'm looking at this as like a codeless test automation challenge. And who I've got over here, this is Artem Golubev from Test Rigger. He has a codeless test automation tool. And we're going to spend the next hour. I've got a list of challenges to see if we can get test automation codeless tools to do. Before we get into that, and I will show you the list of some of the questions over here. If we can get to them all, I promise I won't run over the hour limit here. But with that, let me allow Artem. Why don't you give an introduction? Tell us a little bit about yourself and your tool.
Artem, hi, my name is Artem. Hello, everyone, and I'm a co-founder at Test Rigger. You can check it out. It's a free tool, testrigger.com. Free, not just as free to have, but also free to run on free infrastructure. So, and we help manual testers to build tests basically of the same complexity as engineers would. Using plain English. As soon as you can explain something in plain English, you will be able to do it in Test Rigger.
Cool. All right. I'm sharing my screen. I'm not sure if everybody can see it. Maybe our guys can there. There we go. It is popping up over there. So this is our challenge. This is going to be our Zapple text challenge. And for everybody listening over here, so a couple things I'm going to ask you is if you have a question, if you're like, hey, how can an automation tool do this? I'm going to try and answer or even demonstrate something on the fly. If there's something that you've seen a coded tool do, let us know and think about it. And you can ask questions up on YouTube as we go along. I'm also going to say if anybody else has any other tool, what I'd like to do in the future sessions, I'm going to keep this list and I'll show you the list over here if I've got it available to pop up. There's my list of challenges that we're going to try and get through in just an hour and a couple of minutes here. If you got another tool, this is a list of challenges. I'd like to see if you got another tool, see if you can get it to do this. And that's what I'm thinking about there. So I'm going to get started over here. The first challenge I've got listed here that I came up with was when we're creating test cases, all the test cases should start from a common URL. And it also should do a login. So login is usually the first thing that we do with a tool. So I'm going to use this. This is from Ministry of Test. I have a website out there, and it's nice and convenient because it actually has a login that we can do. You type in, here's the credentials. Keep them. Shh, don't tell anybody. These are the credentials. Admin is the login name, and password is the name of the password. Again, they're pretty easy to hack out there, but it's intentionally done that. So what I would like to do is I'm going to go and basically log into that account. That's the first thing I'm going to do. And I'm going to go over here to our test suites over here and just start something brand new for Zapple Tech. And we will come back to some of the other challenges over there. We'll call this the Zapple Tech login. And Paulie's going to type it correctly. Zapple Tech login. We're going to do desktop web testing. Although I can tell you, Artem's tool also does mobile testing out here. We're just going to stick with this. And I'm going to say we don't need to generate any questions, any automated tests. That's a different feature, not for today. And for Ubuntu, we're gonna use the operating system of Ubuntu, but you could also run on Windows or Mac, and you could also run it on different browsers. But we'll take the defaults of using Ubuntu and Chrome. And here's the thing: I'm going to put in the website, the URL. So we're going to jump in the admin over there. And as you remember, admin. The interesting thing is everybody does a login, and one of the cool things is you can do a login. It's built into the first thing. It's like Artem actually figures out the first thing you're always going to do is try to do some sort of login, and he actually builds in the fields in there to put in the login credentials. So I'm going to put in admin over there. Password is the password, and I'm going to go and create my test suite. Okay, close that. And we don't have any tests built as of yet. So we're going to do this, and I'm going to go add a custom test over here. Let's say login. And what I'm going to do is use this is an implicit rule. There's a reusable rule, and guess what? It's already built into this. So if I just do login, Artem, you verify with me. You think this is going to be able to go hit that website and go log in? I think he's probably going to say yes. Okay, he's saying yes. I think there's a little bit of delay between you and me. So I'm going to hit add and run out there. And I'm going to open this up. And basically what this does is it creates a environment in the cloud. It is going to be a Linux environment because that's what we chose by default. And it goes over there and basically takes screen captures as we go along. And look at this. It ran and it passed in 9 seconds, brought up the environment. And not only that, we're going to go over here and take a look. These are the screen captures of what it picked up. It said it wants to go and log into your account. It actually automatically figured out that there's a button out there it needs to click for logging in. It goes over here to log into your account, and it will go and use the variable names that we stored when we created this test, put in admin, put in username over there, put in password, and then the last thing it did was it went over here and logged us in. And this is our login environment. This is our front page. If I go to RESTful Booker and I say log in with this, we're there, which is pretty cool. That is, I think, less than 3 minutes to create a test on that. So that's a login on there. By the way, we're going to take a look at, let's see. We logged into this. We want all the tests to start from this URL. So let me just verify that we can do that with Test Rigger over here. So if I were to create a new test, we're going to go create a brand new test over here. Or add a new test. Test 2. I'm going to say login as well because we're going to do the same thing. And it's actually automatically chugging away, putting in the queue. The cool thing is under our test suite details, this is the URL. This is the landing page that it goes to. So our first challenge is have a single landing page, have multiple tests, all get to that page when it starts. And look at this. We've got 2 test cases. They both passed. To be fair, they're both identical, but we're going to work on that. Let's go take a look at our next challenge. What was it? Login with credentials, admin and password, all done. Cool. Our next thing is we'll do try to validate a field in a cell in a table. And what we're going to do is we're going to go to this URL. Now this is an interesting table out here. So, and don't forget, you can ask questions out here as we're going through this live and show you stuff. What we got here is a table. I'm actually going to inspect this and take a look at what kind of table do we have out here. Let's take a look at this guy. It's a standard table. He's got a table class. He's got a table head, a body, and we also have rows. We have different values: Yorktown, Spock, Nyota out here, and looks like a trap. There's a little combination he's got going on of, I think, Star Wars and Star Trek, which is really kind of cute. But what we really want to do is we want to go and enter some data into this row here. And again, as I said, this is codeless test automation. So the one thing we want to avoid in that is anything that's really complex, which is, let's say, I don't want to do any CSS, I don't want to do any XPath, and I want to write it like in plain English. So if I go back over to my test, I'm going to use test 2 over there, and I'm going to go quickly edit it. I want to, let's see, open that URL. So we're going to switch to URLs, and we're going to go to this table. And we're going to enter, I believe, texts. Let's see. I like Zapple Tech over here into, let's see. Now, I don't always remember exactly how to do this, but the cool thing is I got some documentation over there. And if I go to documentation, I can look at using tables, which is here, working with tables. There's our sample. And if I wanted to do this, I wanted to enter something into the first table, the second row header ID. Let's say I want to, let's say at row containing this value and content value containing that value. So I'm going to go over here into into at row containing. Now this is what we brought in. What's the row we want? The row in this table I want is, yes, go ahead.
Into table. You should say into table before it.
Got it. Okay, into table. We'll do that. And what I'm looking for is additional data, and I think Spock is what we're going to go for. So we'll do additional data and Spock. Enter into table at row. I think we're going to say Spock. And column. And what was the columns we had over there? I'm trying to remember. The column is additional data. So I'm going to put that in there and populate that guy there. Again, take a look at this, plain English. There's no Java, no JavaScript, no Ruby, nothing to learn there. So enter this text into that, and I'm going to go and hit update and retest. If I wrote it correctly, I get a nice green box that says, hey, you did it right, and it automatically starts retesting. So it is sitting here going that it is in the queue. So it is going to go and jump and see if we get to a pass. Now I got all the way over to this. So it's going to switch over here. In fact, at the bottom, it says open this URL. And then the next page should take us to, there's our sample table. And the last thing we do is it says enter Zappletech into the row. Let's go zoom in on that. Look at that. It figured out that Spock is the row we want. Additional data is the table, and it put that in there, which is kind of cool. Plain English. Wrote it on the fly. Let's just double check. If we don't have any test plan, okay. I'm looking for any question. I don't see anything specifically for doing a test automation without any code, but that's okay. I'm going to go back and see what else we had in our list here. Navigate to another URL. I did that. Validate a cell in a table. Oh, and populate and validate a cell in a table over there. So Artem, if I wanted to validate that I put the word Zappletech in there, I think I would just copy this. Am I correct? I think I would just say check that table contains, something like that. Remember the it's check table. Am I reading that right? Something like that.
It should be input in the context of.
Input in to context.
No. Like check that input in the context of, and then your table thing.
Input in context of table.
Context like CONTEXT, not contact, context.
Context. Oh, context in the context. I'm misspelling this context. probably should just copy it from the, okay, in the context
Yeah,
of.
So remove everything until next word table.
So a table like that.
Yeah, so in the context, the table in the context table has value and then whatever value you'd like to check.
As value. And we'll put in Zappeltech over there. See if I got close on that. I'll hit validate and save and see if I got it. Hey, I got it right. So I'm going to go retest that. So I got the first half of this thing where we are going to go and check that. While it's running, I'm going to jump ahead and take a look. We got our first 3 done. The next thing is validate a sale on table without table structure. What the heck is that? All right, hang on. Let's go take a look. I have a URL over there, and I'm going to go jump to that URL. We'll go to this table 3 out here. This looks, in fact, you know, there's some of there. I'm going to go inspect this this table. I'm going to take a look. And the problem is that this is not actually it's actually put together with divs. There's no identifiable cells or anything in there. They're all just a bunch of divs. And the question is that going to be a challenge for us? Well, let's go jump back over to test rigger over here. I'm going to go and take a look. We do have a past result. So what it does over here is it says, let's see how we do this. This is entering the Zappeltech information in there, which is basically that yellow. I'm not sure why I got this blue in there. Let's try that one more time. So that's why we have the yellow around here saying, hey, I typed in Zappeltech. And then there's another bigger, smaller highlight that's green, which is saying, hey, verify that row that we actually typed in something in the Zappeltech. Works. That's cool. So the next question is, can we do this, but on a table that does not have actually a table inside of it? I'm going to give that, an update and a retest over there. And while that's chugging along inside of the thing, we're going to take a look ahead and see what else is going on here. Next one is create a negative test with expected and actual screen captures is the next challenge. So we'll take a look at that. Let's see. This is the table. This is, just to be sure, I'm going to close this up. I'm going to look at my details and take a look at this URL. See, is this table 3? It actually is table 3. That's cool. And did the exact same thing. Didn't matter whether it had a table or if it didn't have a table structure. It's going. Sounds flaky. Fedora's like, oh, I don't believe this. I see that, Fedora. I see you asking questions. Nice mustaches. Some interesting questions. Sounds flaky. So here's what I tell you about is that one of the things that I do in my automation in order to make sure that things aren't flaky is I take different approaches to finding elements. So one of the first things a flaky test is that what happened? Are there 2 rows? It's Spock in there. Tobias has got a really good question on that. I'm going to follow that up on our next session because I like that Tobias has that for supporting a table that has either 2 lists on there or looking for multiple columns on that. Great question out there, Tobias. I like that, and maybe Tobias, maybe we'll bring you on in one of the other next sessions and maybe talk about that. I think he has another tool. I'd like to see him do that. So, Tobias, you've got the URL from this session, table 3. You can go grab it. Actually, create your own table on there. In fact, I think Tobias has a table as he's going to build on that. So don't worry. Let me get back to the question thing I was saying. So flaky test. One of the major problems you've got with flaky tests is that our darn developers keep changing the way the locators are written for any particular element. So part of the issue with developers for flakiness is stopping those developers from creating a different an element. Changing, let's say, a link. I got a winky face there. Good. Changing the link, let's say, from an anchor to a button. So when I create my frameworks and I do it by code, I'll sit there and say, okay, the a linker, the locator I had doesn't exist anymore. It's now a button. What I'll do is I'll dynamically create another CSS or XPath that is got the same text, but is got a locator that says, okay, let's try it as a button. Let's try it as a div. Let's try it like that. Test rigger does the exact same thing. It goes out there and says, I don't care what kind of element it happens to be. And in this case, same thing. It's two different tables. It still figures it out. It's got a great identification rate. So it takes a couple of different approaches on figuring it out how to find it. And by the way, one of the cool things is that also supports OCR. So worst case scenario, you can use optical character recognition to go and find an element under there. That's my answer over to the flakiness for Fedor. I like that. So let me get back over here. We did this. What was my next challenge? I'm looking at my notepad. A negative test with a negative and positive. Well, I can do this really easy. I'm going to go do this. I'm going to say, check that this has Apple. I'm going to put in Fedora. That's what I'm going to do. Fedora. I'm going to make you so famous. So I'm going to spell your name right, because nobody likes to have their name spelled. So I'm going to do it one more time, except this time I'm looking for Fedora to appear in there. I'm going to update and retest that and let it run again and see it this time. Hopefully we get a failed test and we get some information as to what actually failed. We are back up there, chugging away. And while it's chugging away, I'm going to look at our next one over here. Vertical scaling data drive with a parameterization. Okay, let's see. Some of the other things you can do in here's settings is that how long you wait for stuff. Now, there is a default of settings. I'm going to go over to speed optimizations. There's a default wait-ups of timeouts. This is a fairly fast system, so I'm going to go change my timeouts out to 5 seconds rather than 30 and 60, so that we're not waiting that long for those test cases to fail. So, because I know I'll take a little extra time. I always like my systems. Oh, look at this. We had a failure. Cool. Let's go take a look. Cancel that, please. Get out of here. Yes, I know the password was. Okay, so it says here, we're looking for that. Let me see what the details say. It says, show errors. Field's supposed to have the word Fedor, and it doesn't, and has Zappeltech instead. So there you go. You have your actual and your expected, and we also have a screen capture that says, hey, this is exactly what I was looking for. This is my failure over there. I like that. Kind of cool. Cool stuff there, Artem. I'm going to take our next one over here. What was our next challenge? It said data drive with a parameterized value. Interesting. So what do I want to do? I guess I will go and create some test data over here. And we are going to go create a data set that we will add. And we'll create, the data set is, call it results. Sounds good. Call it actual expected. Call it that. And I'm going to go and add a variable name, actual poly, that's to spell it right. And I'm also going to add expected. We'll do expected. It's not going to work if Poly doesn't spell it right. So the actual and expected. And if I go down here, these are actually, I'm adding variables. I'm not what I wanted. I'm going to go delete these. Made a mistake on this. We're going to go over to rows. Actually, I did do that right, didn't I? Not bad. Okay, one more time. I thought I had made a mistake. I don't second guess myself. Actual results. And I want expected result. Expected result. I'm going to add that. And then we're going to go over to rows. And we're going to add a row. And we have actual and expected values. So one of them is going to be Zappeltech. Get that right. We'll do that. The actual is Zappeltech, and the expected is going to be Zappeltech. I'm going to go add this as expected results. Okay. Most of my time is spent just fixing my mistakes. I'm going to add the expected result, and then I'm going to add another one here. I'm going to add another row, and this is unexpected results. In this case, we are going to, the actual is going to be Zappeltech, and the expected is going to be, this time I'm going to go pick on Tobias. So we're going to do the same thing. So we're going to add that in this, and then I'm going to go back to my test cases, and what I'm going to do is I'm going to link the data set over here. There's my data set, actual expected. I'm going to link that over there. Hit close on that, and I do have to make one quick check on this. We're going to edit, quick edit this test case, and this time instead of Zappeltech, we're going to put in saved value. The name of the saved value is actual, and we're going to do the same thing down here, and now we just basically parameterize this test as value has, I think it's saved value here. I'm correct. Expected. Okay. To be honest, I think I've reversed those, but that's okay. I didn't spell expected that. Expected on that. I'm going to go and validate and save. Got a green out there. I'm going to retest this. And here's the cool thing is I now have this data row drop down over here, which is blank at the moment because it hasn't started and finished the test. It's all sitting up and setting up in the environment. So what it's doing is that we have the data row set of the expected result and the unexpected result. So if we have an unexpected result, it should fail. So we're going to get a fail out of this because one of these two tests is going to pass, one of these is going to fail. This guy coming over here says, hey, we expected to see the expected value in Zappeltech. Cool. And if I switch over to the unexpected result, this is the one that has the different name. And it says, hey, this is something wrong over here. What's our more details? So our errors. It says page doesn't contain Tobias, but it's supposed to. So it actually gave us a result on that basically did indicate that that was not being found in the error out there. Still, it failed. So that is cool. Expected result passed. Unexpected result failed. And one of the other things that Lou was talking about just before here, he's talking about parallelization. Can you run these tests at the same time? And the cool thing is that, yeah, you could have 100 of these test cases and you could go to speed optimizations, I think, down here, and you can have tests. Now, I do want to make sure, I think Artem would want me to make sure that to know that the open source version of this has only one parallelization. Artem, can you confirm with me that if we do it open source,
yes.
Yeah, so it's one parallelization, so everything does run sequentially. You can do that free, and if I remember correctly, it's unlimited users can get on that, right? You can add as many users as you want. Am I correct? Even in the open source?
Yes.
And it's unlimited test cases, right? Is that correct?
Yep.
Also, unlimited test cases, unlimited use. There's no additional cost. When you get to the point where you have like 10 test cases and they're taking an hour to complete, at that point, I think there's a paid subscription on the Test Rigger, which will add you parallelization. So you might get 2 parallelizations. That means get on the screen here. All 10 test cases, 5 of them run at the same time. You could get 5 of them. You could get if you get 10 parallelizations, it would be your results are basically take as long as your longest running test. Everything is basically put together at the same time. And that's where it's all controlled over here is how many parallelizations do you do, which is kind of cool. And this I'm set up for parallelization testing. So I'm going to go back over here, and I do want to be respectful of everybody's time because I know automation stuff is kind of boring. We actually had 20 minutes left on this session. So yes, you can actually run these at the same time. I'm going to show you something. I'm going to rerun this. Let's see. One of the other questions I'm going to do is I'm going to go over here to integrations. And I'm going to turn on recording a video. You saw we did screen captures. So I'm going to turn on video. I'm going to go back over to my test case over here. Close that. Thank you very much. And I am going to retest And then I'm going to jump over here. And if this sets up correctly, we should see 2 columns. There they are. Executing. That went fast. And basically executing down through this. I think this is our previous run. So let me go back.
Yeah, so previous run, you need to wait until new run will pop up.
Until the new run starts up. It's in progress. I got you. I went fast, everybody. Let's try this one more time. Only thing is the test is pretty short and it already got there, but it did run basically both these guys at the same time concurrently. And this is waiting on the failure down here. So that's running in parallel. Let's see what else we've got over here. This is running on Ubuntu and this is on Chrome. Oh, and by the way, this is a video from Vimeo. It's still transcoding, it's still putting it up out there, but it will give you a video of exactly everything that goes on there as it executes. And the reason is it's not built yet is because that last test, that last failure, is still waiting for it to complete. So once it does fail the whole suite, it will give you a video of that. Let's see what our next challenge was. So I did a data-driven of parameterization. I did a video of test. That was for extra credit. Let's see. We did, let's see, a negative test with the actual expect. We did that. We did data-driven with a parameter. So our next one is horizontal scaling. So for anyone who doesn't understand what there's vertical scaling and there's horizontal scaling. Everybody's taught, so it should scale. Well, what does that really mean? It means, well, if you're vertically scaling, it means you did your first test, and then you did your second one, and then you've gotten up test case. This is all basically vertically going up. But then somebody comes over at the water cooler, your CEO comes over and says, "That's great. It runs in Linux, but most of our users are actually Windows people. Can you run this on a Windows system?" Oh, and by the way, there's a couple of Mac people there, and if we don't handle the Mac people, we're gonna leave money on the table. So let's look at that, about seeing if we can run this on different environments. So this guy is still out there in progress, chugging along. So we will come back to that in a second. So what I'm going to do is I'm going to go back over to our settings and show you this, is that I'm going to go and add Windows. We'll add that, and that's on Chrome. And I'm also going to go to Mac and I'm going to add that. So we have Linux, Windows, Chrome. I'm going to save all that, go back to my test cases, and I am going to go and rerun. Yeah, I'll close that guy. And I'm going to go rerun our first test case over here. We'll retest this. And you'll notice that now it says there's Ubuntu Chrome, Windows Chrome, and OX Chrome. So we are now doing horizontal testing, different cross-platform testing, 3 different things. And by the way, I don't need to be bothered with setting up this environment on that. It's all handled in the cloud out of my area. So that's one hat off my head. You'll notice that when you're looking for jobs, and by the way, I am looking for a job. I should mention that. When they ask you for, you want to be an automation engineer, well, you need to have these certain hats. You need to be able to do GUI testing. Oh, and by the way, you need to do API testing. And by the way, how much load testing is doing on this? And you also need to be able to set up all these environments where we are currently running in AWS or some other environment, browser stack, and that's a lot of hats to put on the head. And they said, well, then we'll pay you about $2 an hour for that. It's ridiculous. I don't get it. But this is one of the things I do like about tools, and I always keep an eye on, is like, how much extra work do I have to do? As Lou mentioned earlier in the presentation, he said, there's maintenance that you have to do. And that is one of the major things that goes out with your maintenance. And you have to, that's more time away from you writing test cases, which is was the original goal. Write me some test cases. So over here, I got Chrome, I've got Windows, and I've got Mac all running the exact same tests. So we've done that. We've replicated that. It's also telling us how long it takes for this to show us. You'll see these greens, 1 second and 408 milliseconds. Artem's extremely accurate on this. If it takes quite a while for it to build at some point, then it will actually tell you how long things are going. I did notice on one thing is that you've got some fancy stuff like view or whatever, where you've got stuff sliding in. Technically, the page is built as it's sliding in, but the timing is taking like, okay, it takes about 3 seconds for this thing to come up. And I do know that Artem actually tracks 2 different ways of checking those timing differences out there. All right, so I mentioned this is vertical testing on different platforms, but I did it all on Chrome. So one of the other questions is, can you do it on different browsers? So let me go back over to our browsers. I'm going to make a slight change over here. I'm going to get rid of these 2 guys over here. I'm going to go over here and say, yeah, Ubuntu, I want to do it on Windows, but I don't want to do it on Chrome. I want to do it on Edge. I'm going to add that. And then, of course, I want to go over to Mac. And, of course, no Mac would use Safari. Nobody would ever use Chrome on a Mac. So giving a little shout out to the Mac people on the Safari. So there we go. I've got 3 different operating systems, 3 different browsers. We'll save that, give that another run on our test case. And we will.
To rerun test cases, you probably want to cancel testing and then top run. Oh, by the way, you want to probably turn off the video because
I
video
will
is
do
what
that.
makes everything
That's
5 times slower.
That is a good point out there. Is that video is actually you want to use it when you're really trying to figure out what's going on. So I'm going to take that advice and shut off the video there. I just wanted to point out that it is available.
And then if you go to top left corner to test suite details.
Test suite details. Yep.
Press click rerun with 1 button. You'll rerun all the tests.
We'll rerun everything that's out there. Okay. In fact, and if I open up, I'm going to open up this guy down here. If I go over there, I'm going to go to my execution and see if I did it fast enough. Might still be building. I may have done that too fast again. I'll double check. Let's see. Yeah, this one already passed. This one's in progress. If I can hit it, maybe I can see it because it is a short test. And there you have all these tests. And we have some failures going on out there too. Something else I want to kind of point out there is that one of the things that you pick up on is that there's sometimes stuff that manual testers just don't know what, or to look for results, issues in the page. I want to give you this example over here. Whenever they've got a screen capture that's not red and it's not green, this is yellow. It tells me that there's something going on behind the scenes that got detected. So let me take a look at this. It said that when we hit this, there were 4 JavaScript severe errors that were found. And one's a 404, another one was a 403 errors, and the request was aborted. I honestly don't know what these mean, but I could certainly grab that, send it over to our development environment and say, hey guys, I'm picking up on this. Can you figure out what this is? Because it is a benign error. It's not stopping our test cases, but it is picking up on something, and maybe we don't want this. Could be could be a benign error that could become a problem under some certain circumstance. And somewhere down the line, it was like, oh yeah, we fixed that. It wouldn't. I don't want to turn it into something that blows up and keeps the page from building. So this actually gives me more information than me as a manual tester or even as automation architect could pick up on to identify there. All right, so let me go back and take a look at our challenge list and see what we've checked off so far. We tested on multiple browsers. We tested on Mac and Windows. I think I mentioned they ran it in parallel. The only thing left that got to do is, I think, is extra credit over here, which is a reusable component. That's one of the biggest things about test automation that we want to have, is that we want to make good use of our testing out here for reusability. So let's say I want to do this validation over here. I'm going to copy this text over here. And I'm going to go create a reusable rule, which is something that could be used in any one of our tests. I'm going to put in the text over here. And what am I going to call this? You know what? There is some programming rules for coding rules, and they basically say if you've got something that is a constant, you should always have an uppercase. My general rule here is to do this in uppercase as like a constant in order to make it a little bit more visible when we do this. So I've got my caps lock turned on, and this is going to be validate parameters. We'll call it that. I'm going to, and do I have a space in there? Let's see. Yeah, validate parameters. Okay, I'm going to put this in as our label as well. I'm going to say click and find and replace steps. And what it does, it goes through all of our tests and says, hey, maybe let's see if I can find this text over here. And maybe it was copied because we copied the test 3, 4, 5 times over. And it'll find every version of of our existing test. In this example, we don't have a whole lot of time. Only one test only had it there, but it says, okay, yeah, this is the one I want to use and replace. So I'm going to hit replace selected. And then I'm going to go back over to our test cases. And I'm going to take a look at this over here. And we'll notice that the lines of code that were there, is in my copied it because I copied it. All those lines of code have now been changed into validate parameters. This is the reusable rule that is being used that is combining all those tests. So I can take that reusable rule. I'm going to close that. I'm going to go over to our second test over here, and I'm going to put in validate parameters here. Update and save. Let me just check if there's anything I'm missing. Oh yeah, we needed to open up to the correct URL. That might be interesting. I'm going to copy this and say to saved value regular. Got my caps on there. Open URL saved value, and we will call this table lists. Table lists. Table. Spell it right. Table lists. Table lists. Sounds good. Close enough. Tab lists. I don't know. Tables. Call this fancy table. I'll call it that. Fancy table. It doesn't actually have a table in there. And the other one will be regular table. So I'm going to use fancy table, validate and update that. I'm going to go back over to our test data, and I'm going to go and create a global variable. We'll add that over here. Call it fancy table. And I know I capitalized. I'm going to just double check on that. So there's our one over there. That's our fancy table. I'll add that. And I'm going to also add another one called regular table. And I'm going to put in our regular table, which I know is table number 1. We'll do that. Add that. Go back to our test cases. I'm going to go and edit this. A quick edit over here. And we're going to say this is fancy table. Like that. I'll copy this and validate and save. And then I'll go down to our second one over here. On that, and quick edit this one. And this guy is going to go to regular table. And update, save, and validate. And then I'm going to go back over to our test suite, and we are going to rerun all of this. Yes. So what's our time looking like? 53. I've got actually 7 minutes. I expected not to get to everything on this, and I'm actually finishing it up early. So these test cases are now sitting up there in progress, chugging away. And maybe I might go to this guy over here. I do have a failure down there. I'm going to double check and see what that is. See if that's actual value. Oh yeah, that's because we were checking the name expected in the actual expected results. And I am running in 3 different environments. Let's see if I forgot that I had an intentional failure on these guys over here. So there you are. You've got all these multiple environments all chugging away, running our test cases, passing on the first 3, failing on the second because the second groups are intentionally set to fail because it was looking for Tobias and Fedor instead of Zappeltech on the test case, which is kind of cool. All right. Let me see. I think I covered everything in the challenge. And like I said, anybody has any other tools, go for it. I covered everything. We have reusable components. These 2 test cases use all capitals reusable components. The only thing I got left is, can you do a relative element location on a test? Let's see. Let me take a look. Relative element location. So if I go in to look at the RESTful Booker, and we really just navigated over here and just wanted to verify something like this. Let's see. If I click create, I'm going to think about this for a second. Maybe if I just go to the regular, instead of the admin, I'm going to go here. We'll go to the reservation side. So we're going to go to the reservation side and see if we can do that. I'm going to go to test rigor, our tests. I'm going to add one more test cases. This is relative elements. That. And I'm going to go and open URL. Normally I would put that in a parameter, but don't have a whole lot of time, so I want to do it this way. I already showed you guys how you can do that. I will go there. What do we want to do? We want to, let's go over to our RESTful Booker. And what we want to do is click book this room. So we'll do that. Click book this room. Sounds good. We'll do that. Let's see if this to explain. The third thing we want to do is we get this all this stuff here. I want to enter my email, but you'll also notice that there's an email here and there's an email here. So I'm going to say enter my email below name. Let's try that. See if that works. Enter fake at fake.com. We'll put in a nice fake email into email below name. So make sure I had that right. It is below name, not below first name. We want below name. Above phone. Let's do that. That's actually more. Let's see, into email above phone. And this is a little on the fly, so I'm going to give it a shot and see if we get the right one that we're looking for. Add and run. Says I wrote it correctly, so I'm going to give this a run. We'll go watch it as it is building out the test. It is sitting in the queue. It is coming up over here. And over here it says book this room. Found that button, clicked on it. That's cool. So at this page, we only have all these elements, but we only have one of them. Too easy to automate, not a challenge. And it says put in this near name. And here we had the one on top. So, there was a phone. This is actually the phone up here. So it actually went for phone. Let me go take a look over here. I did have a phone. So what I want to do is, it's actually it's the first one, the first email that was above phone. So what I'm going to do is above subject. We're going to make one last test, and then we're going to wrap up this demo. I will go back over to, close this out, quick edit, above subject, because that one is actually sending an email rather than making the reservation. We need to update and retest and see if we can get that. By the way, when TestRigger does this relative element location, it when it does relative element location, it does it by, you can say near, you can say to the left, above, below, to right, to the left. Um, you can tell it exactly. You can say, I want to do with the exact text in there. So let's take a peek over here. Let's see how close we got. It's a little off screen. So I'm going to go scroll down. We'll make that one more test. I will do this. Scroll down. One more test over here. Guess who I see has just joined us over here? I see a message of Selectors Hub. That means the creator of Selectors Hub is sitting on talking over here. And we've got like 1 minute left to kind of do this. We're right at the top of the hour, and I will wrap up in 1 minute. I do want to make mention that if you do have Selectors Hub over here, and you can right-click on it, Selectors Hub will actually create a test rigger path for you in order to work with that tool. So I wanted to make a mention of that. Let's go back to that test case, and then we're going to wrap things up over here. We have a pass, and what do we get? Check it out. The first email was over here, and this one said, find the email that is above subject. We could have said near subject. We could have said, yeah, I mean, it's, there's a couple other different ways, but that's a relative element location. Guess what, guys? We checked off every one of these guys over here. I will have this posted and available somewhere as the challenge. We'll have the video. I don't see any questions coming up, except for the one that Tobias mentioned, and I'm going to see if I can invite Tobias to kind of show off on that. With that said, Artem, you talked the entire time. I was trying to get some demos going here, and you just took up all the time talking. Any last words before we wrap this up and thank everybody for attending the Zapple Tech Codeless Test Automation demo?
Yep, I think like what I would like to end up with is that I sincerely disagree with previous speaker on the topic that you have to know coding in order to build tests. That is absolutely incorrect. You do not have to know coding in order to build tests, because tests are a linear thing. It's a sequence of steps ending up with the validation, because you're checking that certain functionality works exactly the way you would expect. And for that, you can create any level of complexity test without needing to learn how to program with test trigger. Right. Thank you so much for having me here.
You're welcome. And I will mention when I was listening to him talk, to be fair, I think what he was actually saying, and this is a good point, is it's commonly known that, or considered that you have to use the same programming language that you're writing the application. If it's written in Java, you have to use Java as the automation tool language. That is not true. You can use any language. I worked for almost 12 years paying my mortgage, writing stuff in BASIC, in VB script with UFT. Didn't matter the language on that, on our applications. Anyway, I'm going to thank everybody here for joining us. Thank you, Lou, for that. Thank you, Artem. And if there's any challenges or anything, reach out, ask them questions. I'm at Dark Arts Wizard on Twitter. And you can also catch me at thedarkartswizard@gmail.com. Send stuff over there. Check out my YouTube channel, YouTube. And it is /Paul Grossman, The Dark Arts Wizard, because you couldn't make it any longer than that. And in the next couple months, like I said, I will invite anybody who has other tools with Codeless Automation to step up and repeat those challenges that we've got out there. Thank you so much for everybody attending. I hope you enjoyed it. Have yourself a great day.